All right. Hello, Tom Lowe. Thank you for taking the time out of your day to do this interview. Could you just kind of explain your, I guess, previous work history?
Yeah. So, I mean, I after I left university, I worked in games companies for a few years, and then after that, I moved to a company called Natural Motion. So this is not the same as Rockstar Studios. It's a separate, smaller company, um, and they were making animation technology software. So um, they sell their software to different companies, to games companies. So one of the first games companies that took up this software was Rockstar, Rockstar North that made Grand Theft Auto 4. I've even got the original packaging
Oh, that's cool.
box set here.
Oh,
Um,
wow.
yeah, so that's
Yeah,
Grand
the
Theft Auto
camera's
4.
it's kind of struggling with the auto background, but yeah, you can see it.
Yeah. Okay, you can just about see it. Still in its packaging. Um, so we were making quite an interesting technology that really, as far as I know, has not been kind of replicated since then, which was to take the concept of ragdoll physics, which was very popular at the time, and extend it so that your character that's been hit by something is not just a loose ragdoll, but there's actually some force going into their muscles, or force going into their joints, some torque. And then our job was specialized in how do you control those joints in order to make the character, while at the same time as being physical, also be believable.
Yeah.
Um, and the idea here was not to replace character animation throughout a game, but to do a better job with those situations where the characters become dynamic.
Right.
So an
So
example.
you would have for like canned animations, like you would animate the characters traditionally without simulating the joints. And then when it came to having ragdolls, you would then switch to simulating the muscles so you could have the realistic ragdolls.
That's right. It started with just a very small incremental improvement upon ragdoll physics. So, for example, if you shot somebody, then typically in games at the time, it might swap to ragdoll physics. So it just pop over into a physics simulation and the person would collapse like a ragdoll. So we wanted to start off with to do things like, well, what happens if the person's not dead? Should they reach for the place they've been hit? Should they, if they fall over, should they put their arms out in front of them?
Yeah,
They try and twist their body, maybe look at the ground. These sort of small behaviors to just make the ragdoll a bit more believable in situations where they haven't just completely died. But then as we progress through it, we're able to make it work in situations where the person clearly has not even necessarily been injured. So a situation where you're in a crowd and this happens in Grand Theft Auto, you run through some people
yeah,
or your car slowly hit them and
yeah,
it pushes away and they get knocked. And so you want the person to step and sort of stumble in the direction that they've been knocked in. And so, in order to do that, we had to start physically working out how to make the legs move so that it's not going to fall over. So, essentially,
yeah,
a type of physical walking behavior.
yeah. One thing that comes to mind, have you seen those videos where like people like train AI models to walk and they'll like simulate the muscles and the joints and they'll like do like thousands of iterations and like slowly the AI like learns how to like move its legs in order to like not fall over.
Yeah, that's right. Yeah, I love those things. They're great to watch. In fact, when I first joined Natural Motion, that was one of the ideas they were promoting, where you kind of evolve
Yeah,
these behaviors. But once it came to this paid job to get these things done, we
yeah,
opted for more, I suppose you call it a more traditional approach because we
yeah,
were using code to program and scripts to try and work out what the physics
yeah,
should be.
yeah.
Um,
Because Yeah, that would have been quite difficult to have it be like use AI to
Yeah,
generate
I
walk
think that, I
cycles.
mean, this was a while ago now,
Yeah.
so it was a good 15 or so years ago. So now probably the technology's tipped over that it may be a better
Mm.
solution to just go with these evolution methods. But at the time, it was the dependability and the
Yeah.
ability for a customer to say, "Oh, can you change this?" and we would be able to change it
Yeah,
for
you
them.
don't have to like figure out all the like reinforcements and stuff.
Yeah, that's right. Yep.
Um, all right, so what if you don't mind, what exactly was your job title?
Ooh, I'm not even sure what it was. I mean,
Mm.
senior, um, I was a senior programmer,
Right.
um, and I was a kind of a head of a group of about 6 or 7 people.
Okay.
Um, but I wasn't really people managing. I was there to write the algorithm, so I did a lot of the actual
Right.
thing on it. I did the staggering, kind of primitive walk type behavior. And well, I did a lot of them. There's one where if you get blown through the air by some explosion or something, they like the idea of cartwheeling your arms a little bit, which it's one thing to just say, okay, people seem to cartwheel their arms, but it helps in this case to go a bit deeper and go, why are people
Yeah,
cartwheel
yeah.
your arms? And it
Yeah, to
turns out that
like
you kind of do it to avoid hitting your head
yeah,
because it
to
kind of
maintain balance.
that's right. It's a bit like cats always landing on their feet. There's a few things that people kind of
Yeah,
naturally,
it's like
almost instinctively do.
yeah, there's like a word for it. I forget the word, but it's like I don't know. Um yeah, so what was it like working as a contractor for Rockstar?
It was nice. Yeah, you know, we were we were a company of about 25 or 30 people maybe at the time. We weren't too small. And we did most of it just from Oxford, where we were based. And um, we didn't, it's called co-development because they were developing the game and we were developing
Yeah, the animations.
technology at the same time. So there would be an interaction where they would say, "Oh, okay, can you make this work a bit more this way?" And then we did, and that would feature in their game. Um, and then we visited them a few times, not too
Oh, that would
many,
have
but
been cool.
yeah. So we got to see the studios up in Edinburgh.
Right. Right.
So there's quite a few people that are surprised to find out that the Grand Theft Auto is primarily written up in Edinburgh,
Yeah,
but it is.
yeah. Yeah, yeah, it's a British company. Yeah, which
Yeah.
is fascinating because I'm pretty sure the game Bully is set in the UK, but pretty much I don't actually I want to say Bully set in the UK, but yeah, all the GTA games obviously they're all set across America and they're all satires of America, but it's made by a British company.
That's right. Yeah, they've got an office in the States as well. We
Yeah.
went and visited in San Diego, and they were making some other games. So because what we're making is like a core bit of technology, they were able to apply it to other games. So at the time, they were trying to get it into Red Dead Redemption 2, I think it was.
Oh yeah.
And yeah,
Yeah, I think Red Dead Redemption 2, I remember from playing it, like a lot of the animations have a real weight to them. And like when you like whenever you press a direction to move in a direction, like Arthur doesn't move there immediately. He he staggers a bit, he like takes his time and everything has
mm,
like a real heft to it.
mm. Yeah, so that might be the tech that we were using. It was called
Yeah.
Euphoria. So we sort of sold it as a package called Euphoria at the time. So it could well have been, yeah, that. that technology, and also just localizing things to the character. If you're shot somewhere, you want the person to get knocked back from, if they're shot in this shoulder, get that kickback in the right area of the body. And again, if you're getting knocked to the side by a horse or whatever, or spun around, it's just all about trying to make it a bit more engaging, I guess. But for
Yeah.
me, it was interesting because I'm not so much, it's not my priority whether the game is engaging. I'm just interested in the physics of it. I'm
Mm,
interested in how
yeah.
humans move and what makes them behave the way they do, and what's the kind of physics of um of how people do that.
Yeah. So, are you much of a gamer at all? Have you played any of the GTA games prior to working on GTA 4?
No, I am not much of a gamer at all, though I
Right.
do like making games. When I was young, I made quite a few games, not to sell commercially, but just
Yeah, just as
make
a fun
fun.
hobby.
And then, like I say, after university, I spent about 4 years making games in Australia.
Oh, cool.
Uh, yeah, I don't know if you know Chrome Studios. It used to be a lot bigger, but it's still around.
I
Um,
haven't heard of them, but maybe I've seen some of
yeah,
their games.
yeah, they're based in Brisbane, Ty the Tasmanian Tiger. Well, even The Force Unleashed as a licensed
Oh,
game.
okay. Yeah,
The
I've heard
Star
of
Wars
that. Yeah, that
was,
was for the Wii, I think.
mm, that sounds about right. Yeah, was made by them. Um, yeah, so I did have that sort of background in doing games, and I actually, towards the end of my time working in games, I was starting to write physics engines and do the ragdoll physics for games. So it's kind of a natural job that I took next was the one with natural motion.
Cool. So, with the ragdolls, how exactly did you determine when to switch to the ragdoll and when to switch back, if you can
Yeah,
remember?
it's
Because
yeah. I
I can
mean,
imagine that
it,
being a kind of a difficult problem to solve.
yes and no. It tended to be quite obvious situations. So you'd
Yeah,
Um, if the person was getting shot, then it would switch. If they were hit by an explosion or hit by a car, they're getting switched. And if they were bumped into, it would switch over. We didn't do the code for when to switch, but they would probably base it on some kind of velocity threshold
right,
and say,
right. If you're like
not.
experiencing a certain amount of force.
Yeah, I think that's would have been how you did it.
Right.
You're going to be, you really want something physical to happen here and not just the character to slide away from the car, keeping its canned animation.
Okay.
Yeah. So it was
Um,
extremely difficult to do. And one of the problems we had was physics engines, because even though when you have these physics engines, all the demos look really great, once you start doing character physics, it's a much harder problem for the physics engine to solve. And the main problem is that your character has got small little feet with small mass, only a kilogram or so of mass on the feet, and then a big long chain of larger mass objects all above it. And it turns out that a lot of physics engines that do iterative physics solvers, they have a lot of problems with that, and the feet end up jittering on the ground, and they fit through the ground. And the strength in your ankle, because people have got a lot of strength proportionally, they've got a lot of strength in their ankle. The strength in the ankle is not high enough, and so a lot of the initial problems we had were actually the physics engine. But fortunately, Rockstar had an excellent physics engine and still does.
yeah.
Um, and that really helped us to get good quality character physics. Even though, a falling brick wall or something might look the same, for the character physics, it made a big difference.
Yeah, yeah. If you're, yeah, calculating forces on characters and having them dynamically react to that, for sure, you would want a solid engine behind everything. Um,
Especially for kind of walking and staggering behaviors where the feet matter a lot, and the balance, a lot of it's done with the feet. So yeah, it did make a difference.
Another question I have is like, how would the ragdoll change with if there were like, for example, hazards nearby? So say a character gets pushed, and then there was like a body of water nearby them. Um, how would you ensure that the character wouldn't that they would basically have an instinct to avoid the water? They wouldn't just stumble back directly into the water as I guess a normal person would when they were getting pushed.
Yeah, well, we didn't do that. I mean, basically,
Right.
they would stumble into water.
Okay.
You could also push into them, and they would stumble downstairs. You know, I think that stairs are so dangerous that a real person would really, even if they've been pushed and barged into, there'll be something instinctive in them that would really somehow avoid
Yeah.
falling downstairs.
Yeah,
But
your
they would fall
brain wouldn't let you
downstairs.
just like hit your head on the stairs and then fall down.
Yeah, or you would lower your center of gravity or something to prepare for that.
Yeah.
You'd have an awareness of the stairs, but they really didn't have an awareness. The balancing and the staying upright didn't have an awareness of the surroundings. It wasn't that level
Right.
of
So
AI, you could say. But they would fall down the stairs, but in a way that worked because it's more spectacular and
yeah, it's
dramatic.
funny when the
It is
NPCs just
funny.
drown.
It's kind of funnier when they push over. And you know, we a lot of the behaviors, especially early on, they kind of were a bit floppy and they looked like the person was drunk. And so it was kind of a deliberate decision to kind of put in a drunk scene into Grand Theft Auto because we could sell that part of the behavior. And later on in our co-development, we were able to kind of improve the quality of the behaviors. So we didn't it didn't look like that all the time. But yeah, that is one of the parts of the co-development where you work off each other to decide what to do with it.
Yeah, of course, you kind of make the most of your limitations. Um, all right. So you started off as a game developer and you slowly um moved into like you said, animating animating the physics of characters, doing like having them react to forces and stuff, and then that kind of led you out of game development. So what was kind of your career trajectory after doing Grand Theft Auto?
Yeah, I actually pivoted, I guess you could say, after that. I mean, it was after Grand Theft Auto, I was still working in actual motion, so we continued to develop the technology, and we had um, some kind of fun ideas where we were really generalizing the behaviors, and we'd set up these kind of gym scenarios where you'd have a virtual room with virtual equipment in it, and you would have kind of situations where the characters were kind of set up in very physical situations. Maybe there's like a wrecking ball that's coming and repeatedly hitting the character, and it needs to go from animation into the physical thing, and then it needs to turn its head and look at the object that's moving. And then when the object hits it, it needs to put its arms against the object, and then it needs to start stumbling backwards to keep its balance as the object is pushing it.
Right. So you're
You know,
starting to have the characters react to environmental factors when you're having
yeah,
the ragdoll.
that's right. We were working towards a very general sort of capability where you're in a very dynamic environment that's got lots of things. Maybe the ground is moving, maybe it's slippery, maybe um, things are hitting you, all of that stuff. Um, and so we'd set up this kind of virtual gym environment just so you can have an overview of how it's doing. You change the code and you can run it again, and you can kind of have a nice overview of um, how it affects the characters. And um, we released, just after I left, actually, we released a game called Clumsy Ninja,
Oh,
which
okay.
was um, which was kind of based on that. It was almost 100% physical, I think, where you could prod and push this little character around, and it would try and act kind of according to the kind of more instinctive behaviors that people might do. Um, and it was all super interesting for me. You know, it's very I love that. I love all the physics involved and also the biomechanics
Yeah,
involved
yeah, or like the
in it.
kinematics.
Yeah, and one of the things that really stood out quite early on is that you can't, you see, you model the person with all of its limbs and you make like a nice capsule for one of the parts of the leg and another capsule for the femur and tibia and things. Um, and then you'd have joint limits, you know, your leg, you don't want your knee to bend backwards, so you've got a joint limit and you've got another limit. And you discover quite quickly that if you just put in all the correct joint limits, um, the ragdolls or the behaving character looks really unrealistic. And the reason is that you can quite easily get your foot right up above your head, because we know that your knee can go straight, and we know that your if you've got a bent knee, you can bring your knee right up to your chest. So it stands to reason that you could put your knee up to your chest, extend your leg, and your foot could be touching your forehead, which looks ridiculous, right? So that's the reason people don't do that is a hamstring. So we had to learn about hamstrings and these kind of multi-joint um, bits of dynamic that
Yeah,
go on inside the human body in order to, and once we got those things in, then suddenly you're in a more of a winning situation where even if your logic's a bit bad, the physics engine's going to give you um, a much nicer looking
yeah,
character movement.
yeah. You pretty much have
But
to reverse engineer evolution or the evolution of the human body.
yeah, or at least yeah, look up some biomechanics manuals. We did a fair bit of kind of videoing colleagues and pushing them to see what they do, and then pushing them harder and see what they do, and pushing them unexpectedly to see what they do, to see how people behave. So all of that was very enjoyable. And then after that, I kind of pivoted to working in robotics,
Oh, okay,
which
yeah,
is not totally different
yeah,
because
yeah.
we do have a humanoid robot at the place that I work now, which is CSIRO. Um, but you know, it moved on to doing other things really unrelated to game animations and biomechanics.
Mm. If you don't mind answering, what do you do currently at CSIRO?
Yeah, so I am in the robotics department, and we do have robots with legs, and we do have a humanoid robot, but I'm not working on those directly at the moment. We've been doing a lot of making maps, 3D maps using sensors like LiDAR sensors. So you want to be
Oh,
able to
okay,
walk around a building and get maps of it and work out what to do with those maps.
cool. Um, okay, so that pretty much covers your work history with Rockstar. Now I kind of wanna um ask you more general questions. What do you think of like programming trends? I guess mainly AI. Um, I know a lot of people I think there's like a hot debate over Rust. Some people are really in love with it. Some people say it's terrible and you should never code anything with Rust. Um, what do you think about that?
Um, I I'm using it. Well, I'm trialing it. We've got Git Copilot and using a few different ones for them. I don't find it that good at the moment,
Yeah.
particularly there's one, the autocomplete thing just annoys me, completely
Yeah.
annoys me. It's like being at a in a party and you're trying to have a conversation with someone and recite some anecdote, and then there's somebody just over your shoulder trying to guess what the end of your sentence is and continually tell you what the end of your sentence is all the time. So
Yeah, it is a
I found
bit
it
like that using AI to code. Because,
yeah, so the autocomplete I just found really annoying. And I gave it a week. So maybe if I gave it longer, I would find it better, but I didn't like it at all. The ask feature, which is basically like just going to Gemini or something, but it knows about your code, so it can give you a more helpful answer. I found that okay. It still makes lots of mistakes, but it's all about finding where it's useful and where it's not going to be useful.
yeah,
So some things like some really obtuse bug that just doesn't make sense, instead of wasting 4 hours trying to research it, often you can just ask and
yeah,
it'll
yeah. If
have a
it
go
can
at
give
an
you,
answer.
if you can give it code and it can point to like a very specific thing, it's like, oh, this, I don't know, this if statement is wrong, you're checking for the wrong thing. Or like, oh, you
Mm,
haven't declared this variable's undefined. It's really good at like checking for that obvious stuff that like would take
yeah,
a human a while because like when you like write something, your mind automatically fills in the blanks. And if you write code, it can be like that sometimes where
yeah,
like
yeah, you become
your
blind
brain
to
will
it.
like, yeah, fill in the mistakes and so you don't recognize them. And it's almost just like having a second person look at it. But if the source of the error is like not obvious, I find it'll start like doing like random things. Like it'll, I don't know, mess with the configuration file or like mess with other files, and it just makes the code more complicated and it's not even solving the root issue. And it
Yeah,
just goes round
that's the
in
edit mode
circles.
in Copilot. That's the edit mode where it starts messing with your code for you. So yeah, I generally haven't used that much. Some people do, but there are some situations where it's great if you're opening somebody else's code base, you can get a summary of the code
Yeah,
base. That's quite nice. And I think you've just got to have in your mind what it's good at and what it's bad at. And I think
yeah,
it's good at going wide. It's good at compiling together huge, tens of thousands of lines of code and giving you summaries, but it's not very good at going deep.
yeah,
Um,
yeah.
so
You're pretty much just talking to Google basically, because these AI models, they have massive data sets. So if it's like a simple query that's like easily answered, like it's like, oh, I'm using this library. I want to do this like specific thing that probably like thousands of people have done before, then it can really easily tell you how to do that because it's been trained on that. But yeah, if you go too specific, it like breaks down because it hasn't been trained how to do
yeah.
those things.
So I've not it's not hit the button for me of it being revolutionary.
Yeah.
It to me it doesn't match the hype. Maybe it will,
Yeah, it's hard
but
to say.
um, who can tell you that, it I think it's useful. When autocomplete first arrived in coding, that was useful. And
Yeah.
this is useful as well if you know how to use it the right way. But I'm not at the stage of declaring it a revolution.
Yeah, I think AI definitely has potential. Like it has a user base, like people use it and find use out of it. But we're definitely in a bubble right now. Like, um, oh, the meeting will end in 10 minutes. That's okay, because I think we're gonna wrap up soon anyway.
Mm,
Um, but yeah, I think what was I gonna say? Oh, we're in a bubble. Like the top, pretty much the S&P 500 right now. It's just composed of like NVIDIA, OpenAI, and all the other AI companies. Like the market right now, it's so top heavy with AI,
mm,
and it's the question. I think everyone knows it's a bubble, but just the question is when it will burst and what the implications will be.
mm. And also, what's the implication of a world where nobody really understands the code? It's just prompts that's given, in a quite a blasé way to AI to develop these things. It goes back to the physical animation. It was really very interesting to learn the biomechanics and learn the psychology and learn the instincts that people do and how it translates into torques and forces in your body. That's great. It's a really interesting skill
Yeah,
to learn about. Very enriching, I found.
yeah,
Um, the 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 evolution based ones are fantastic. They're exciting, but also you don't end up with any insight at the end of it. You've got something else to do the job for you, and that
yeah.
it's
It's very
lacking of
difficult to figure out
that
exactly
craft.
why an AI model does what it does. Because it's just a bunch of weights at the end of the day. It's just a bunch of numbers. And it's like, what do these
Yeah,
numbers mean?
yeah. And essentially, it's found a way to model it, but you've not had to even think about it. But I think, you're missing something from that.
For sure. Um, all right. I think I'll ask one more question. I see a lot of discourse online about object-oriented programming. Um, when I was in university, they were pretty like hardcore about it. Like as I think a lot of institutions are, they really hammered on about like C sharp and using classes and using interfaces and like I guess having a hierarchy of classes and like if like your parent class has some behavior, then you inherit it for the child class. And a lot of people say, oh, it makes your code more complicated. There's like unforeseen bugs with inheritance. It's a waste of time. Don't use object-oriented programming. Personally, I think it's quite useful for game development where it makes sense to have classes that inherent things, and it just makes sense to have it that way instead of having it procedurally programmed. Do you personally use object-oriented programming, or do you kind of stay clear of it?
Yeah, no, I agree with you, Dylan. I love object-oriented programming.
Yeah,
I think it's possible to overdo it where
yeah,
you've
for
just got
sure.
these huge hierarchies. I've seen hierarchies that the base class is just called object. It's so general that they couldn't even think of a better name than object as the very base class. And I think it's possible that you can go too far with it. And also all of these, maybe interfaces, multiple inheritance. There's all sorts of things you can do with it. But if you're
Yeah,
kind of using it in quite a more sensible normal fashion, I think it's great. There's people that really espouse functional programming.
yeah,
Personally, I don't find that great for coding. I like working with objects.
yeah,
Your methods and your data are packaged together nicely as an object, and I'm happy
yeah.
with
I
that.
think, yeah, for sure. You can 100% overdo it and have like a crazy structure. And I remember I had like one university assignment and it was using C sharp and they said, "Oh, it's like you have to use an interface or something." But like the problem was you could like do the assignment without using an interface and it worked fine and there was no reason to really have one. But then of course, because to get full marks you needed to have one, you had to kind of like ham fist it in and like have the code set up in a way that like didn't make sense just to fulfill that requirement. And I think that's a case where it goes too far. But obviously, if you like, you don't. The thing is, you don't have to use all the fancy features. You can just keep it simple.
Yeah, and that's what I tend to do as well. Yeah.
Yeah,
Friend classes and protected and yeah, there's
yeah,
quite a lot of it. Yeah.
yeah. All right. I think we've been going for about 30 minutes. I think that pretty much covers everything I wanted to ask. Thank you so much for taking time
Yeah,
out of
no
your
worries,
day, Tom
Dylan.
Lowe. Um,
It's very enjoyable. Thank you.
all right. Bye.